In this video, I'm going to explain how I went from taking the raw data about the motorists to actually creating the general linearized model. To begin with, I imported the data from a CSV file and I've got it in a spreadsheet here. There's two things I need to explain about this spreadsheet. First of all, if you could have a look at these first four columns. The column A simply represents the policy number. So for each row, there's a different policy, or each policy has a different row. In column B, we've got the number of claims. The number of claims is actually difficult to compare because people take out policies for different lengths of time. And that's shown in column C, the exposure. That's just how many years the policy was taken out for. So if you have a look at row 2, the exposure is 0.1, which means that that policyholder took out their policy for 0.1 years. So if people take out their policies for different lengths of time, it makes it quite difficult to compare the number of claims they make. To get around this, I made column D, which is the number of claims people make per year. And the first problem arose when I made this column because some people had only taken out policies for a very short amount of time. And it meant that when I worked out the claim frequency, the number of claims they made per year, it gave me extremely large numbers, which could potentially skew the model. And so to get around this, I actually deleted any policies that were for a duration of less than 0.1. The second thing to draw your attention to with this spreadsheet is that I've taken a lot of the data and put it into groups. So for example, if you come over and look at column I, which is the age of the driver, I've put that into groups in column J. Now, I'll talk about this a bit more later, but the main reason is because the relationship between the driving age and the number of claims someone makes per year might not be linear, and I'm creating a linear model. By putting it into groups, it helps me get around that problem. It also makes the coefficients will make a bit more sense in the final model, but we'll talk about that in a moment. So this is the data, and my first step was to try and get a feel for the data, and then try and ascertain which variables had a bigger impact on the number of claims compared to those that didn't. Because there is a lot of data, and I think there's too much really here for Excel to handle, if I'm honest, I'm not actually going to, or I decided not to use all of the variables in the data set. So what I wanted to do was just kind of select which variables affected the number of claims the most. So to achieve these two aims, I created some pivot tables, which I will show you on this spreadsheet. So if you have a look at the top of this spreadsheet, first pivot table is for area. So what we have is 6 areas from A to F. So you can picture the area of France split into 6 areas, and each area is assigned a different letter. And in this second column, which I will highlight, you've got the average claims per year for each region. And I'm trying to work out, is there some sort of connection between the area the policyholder's in and the number of claims they make per year? I concluded from this pivot table that area does affect the number of claims someone makes per year, because if you have a look at the top row, it's 0.09 and it gradually increases to area F, 0.16. Therefore, I decided to include area in the final GLM, in the model. If you look at the second table, over here, the power of the vehicle, we've got, so vehicles can have a power from 4 to 15. If you have a look at the claim frequency, I don't think there's really much of a relationship between the power of the vehicle and the claim frequency. So I decided not to include vehicle power in the final GLM. You can see I did that for each variable, and if I scoot to the right, these are the variables that I decided to include in the final GLM. There's 5, so I'm including area, age of the vehicle, driving age, bonus malus, which is just no claims, and the population density. Okay, so I took this data and I put it into another spreadsheet where I created some dummy variables and then ultimately made the GLM. And that's in this first sheet. Just give me a moment. So first thing to say is, on this sheet, I just made some extra columns. If I go along again to driving age, so I've highlighted that here, T. So this is the original data. As I said a second ago, I put the data into groups, and you can see that in column U. And then for each group, I made a dummy variable, and you can see that in columns V to Y. So as I said earlier, that helps me deal with the fact that the relationship between driving age and the number of claims per year, it might not be linear. And ultimately, I'm making a linear model here. And also, it makes the coefficients easier to interpret. And that is my final goal, to get these coefficients for the linear model. Excuse me. Okay. So there we go. There's the final way I just changed the data slightly. I didn't change the data, but just perhaps used it in a different way. Now I'm going to show you what the final objective is to the model, and then we'll quickly rewind and look at how we got there. So this whole project is pointing towards this table here. If I can just come down. There we go. So underneath the heading parameter, you've got all of the variables that we're trying to find coefficients to, and in the middle column, I've got the optimized coefficients for each variable. Now I've already done the project, so these are the optimum coefficients here. But originally, when I created this table, I didn't know what the optimum coefficients were. So in this middle column, I just had to have guesses at what these were. So I made them all 1. And then essentially so when they were all 1, my first guess at the number of claims that everyone was made, that people made per year, was simply an addition of the variables, which was not a very good model, but we'll get to how we actually found these values. All right, so that's what we're trying to do. We're trying to, in this project, is to try and guess what these numbers are that I've highlighted. If I come back to the data, at the end, I've got these, is it 5? I've got these 5 columns here. And this is essentially my input, where I'm putting formulas into each cell to find these coefficients for the GLM. So if you have a look at the top row, I've just highlighted, is it AL row 2? It's got minus 2.13 in it. So this is the first function I've put in, a linear predictor. So what this column represents is, this is my guess at the number of claims this person's going to make, this policyholder in row 2, per year. It's this cell is made as a linear combination of all the variables in this table. Excuse me. Just give it a moment. Okay, this is actually one of the problems with using Excel. There's too much data for it, so it's sometimes takes a little while to do what it needs to do. Okay, Excel froze there, so I've briefly had to make a new video. Obviously, there's too much data for Excel to handle. But if we go back up to the top row, I'm just going to highlight it here. So for this policyholder, they made one claim for the time that they had the policy. In this cell that I've highlighted, this is my prediction for how many claims I think they're going to make. And this cell here that I've highlighted, AL number 2, it comes from a linear combination of everything you see in the table on the right. So the parameters, area B, area C, area D, all the way down to density 1002. As you can see, it's not a very good prediction. I'm predicting that this first policyholder is going to make minus 2.13 claims per year. But in fact, it's not the number of claims I think they're going to make per year. It's the logarithm of that number. If I actually want to get the number of claims that they make per year, it's to the cell to the right, this one. So I've just taken an exponential of my guess, and it's 0.118. So just to recap briefly, this first cell in the column linear predictor, that is my guess for the number of claims per year, or the logarithm of that. To the right of that, we take the exponential of our guess, and it's the actual claims per year. So I'm guessing that this person, this policyholder, is going to make 0.118 claims per year. Okay. I then want to work out how many claims will they actually make for the length of time that they have the policy. And this top policyholder in row 2, they held a policy for 0.1 years. So I'm going to multiply this frequency by 0.1. And you can see that value in AN. So AN, it represents how many claims we predict this person to make over the duration of their policy. So we predict them to make 0.0118 claims, even though we know they actually only made one claim. So it's not looking like a very good prediction at the moment, but bear with it. So based on this number that I've got highlighted, this is the number of claims we think they're going to make in the duration of their policy. We then use a Poisson distribution and we say, right, okay, if 0.0118, if that's how many claims we think they're going to make, using a Poisson distribution, what's the likelihood that they actually make one claim? That was how many claims they made. In real life, they actually made one claim. And the likelihood that they actually make one claim is two columns along here in AP. 0.0116. Quite a similar number, just coincidentally. So that's the likelihood that they actually make one claim, which makes our model, or makes the model that I've come up with not look terrific. If you take the log of that, you get AO. And essentially what we're trying to do is we're trying to maximize the log likelihoods, the likelihood of each event happening for whatever happened. And the only way that we can maximize these likelihoods is by changing our coefficients over here. These are the coefficients for our linear model. Now, there's only one more step to this. I've added up all of the likelihoods in AO, or the log likelihoods. And the sum of them is in this cell here, AS5. I then used Excel's solver function and by just putting a couple of inputs and telling Excel to focus on changing these cells to maximize the value of the total log likelihood, we can find these optimum values that I've got here. Now the optimum obviously is a linear model, but if you take the exponential of these values I've highlighted, the log values, you get some values which make a bit more sense to the right of them over here. And these kind of tell us the factor by which each of these variables affect the number of claims someone makes per year. And that's how we come up with the GLM.